We're looking at 9 for more rational exponents. So basically a part 2 to 9 for rational exponents. So the goal today is to simplify with no calculator. What I really want you to remember is that PEMDAS applies everywhere in math, even when we're not dealing with numbers, even when we're just dealing with variables. So we're really going to rely upon PEMDAS a lot today. So to simplify this first expression here, we're going to take care of the power to the power, the exponent. So remember, power to power means we multiply. So we have 1/3 times -2. So this would become x to the -2/3. Then in math, as you know, you're not allowed to keep a negative exponent. So we have to place the x to the bottom of the fraction, which would make this a positive 2/3 exponent. But then we know that having an exponent, a fractional exponent, really means a radical expression. So we're going to convert this to a radical expression. So this is cube root x squared. And then again, further, we know that we can't keep a radical in the denominator. We must rationalize. So since this is cube root of x squared, it's cube root, you need 3 of the same thing, then you need to go ahead and multiply by another cube root of x on top and bottom of this fraction, because what that would create here on the bottom is cube root of x cubed, because x squared times x would be x cubed. So then on top you would have just cube root of x, because you were just multiplying by 1, and then the beauty in cube root of x cubed is that you have 3 x's, so a single x will come out, and you have cube root of x over x, and then you're finished with that one. Okay, quite a long one. Here on this, we're going to deal with power to power again first, but what I really want you to remember is that the 2 also has a power of 1. So this 2 as an exponent distributes to both of these exponents inside here. So what we're going to have is 2 squared x to the -4/7. Okay, the 2 squared, as you know, becomes 4. Okay, 2 squared is 4. That's going to stay on the top of the fraction because that's a positive 2. This, however, is a negative exponent, so it needs to, this x needs to move to the bottom of the fraction with its exponent so that the exponent can become positive. So now, again, you're going to convert that to a radical expression, so 7th root of x to the 4th. And then again, you must rationalize. Since you have 7th root, you need 7 of the same thing for anything to come out. So you've already got 4. You need 3 more to create 7. So you would have 4 7th root x to the 3rd over, this would become 7th root x to the 7th, which would produce just an x that comes out of the radical. So 4 7th root x to the 3rd over x is your final, not so pretty, but that's your final answer. Okay, on this problem, what we're going to do first, because I noticed something can be simplified in the parentheses for P for PEMDAS, I'm going to do that first. Okay, here on this problem 2 is a prime number. I couldn't do anything with that. 25, I know that 25 is 5 squared. Because I have a power up here, I'm going to convert that to 5 squared because it might help me with my power here, and that's just a good rule of thumb to do from here on out. So 25 is the same thing as 5 squared, so I'm going to rewrite it as such, and then x to the -12 can't be simplified really yet. Okay, all raised to the 1/2 power. Now this helps me converting this because now when I distribute in, watch what happens. I've got 5 to the 2 times 1/2 is 1, 5 to the first, x to the -6. -12 times 1/2 is -6. So I've really got 5 to the first, so just 5 that stays on top because that exponent is positive, and then x to the 6th on bottom to make that negative exponent positive. No rationalizing needs to be done, so I'm finished with that one. Okay, on this problem, nothing can be done inside. I don't really want to move that down to the bottom yet because it's a negative exponent because I want to deal with the power to power first. So here when I distribute in, that gives me 2 to the +3rd power x to the 5/3 times -3. If you can't see it, what's going to happen there, then do it off to the side, but that's going to become -5 okay? And then 2 to the third simplifies to 8, and it's a positive exponent, so it stays on top of the fraction. This negative exponent needs to move to the bottom to become a positive exponent. Okay, nothing else can be simplified there, so you're done. Okay, so moving along here, notice that this -2 power only goes to the x, not to the 4 on the outside. So we're going to leave the 4 on the outside alone, and this is going to become x to the -4/5 when I raise my power to power and multiply. And then I know that that means the 4 is going to stay on top, because remember, it's got an implied exponent of +1, so it stays on top. X to the 4/5 on bottom. Now that exponent becomes positive when it moves to the bottom. But again, you must convert that to a radical expression. Okay, and then to rationalize, you need to multiply by 5th root of x on both top and bottom. Therefore, you have 5th root of x to the 5th. And then on top, you've got 4 5th root of x. And so you would have 4 5th root of x over x. And then you would be done. You've rationalized. Okay, so moving on here. Again, this is PEMDAS. In the parentheses, clean up first if you can. I do notice 12 over 3 simplifies to 4. And then y to the 5th over y to the -3. Okay, so first of all, I'm going to take care of the 12 over 3, which is 4. Recall that if you have something like x to the 5th over x squared, that's x to the 3rd, because when you have common bases, same bases, you subtract the exponents when dividing. So 5 minus 2 is 3. Okay, here I've got common bases, they're both y, and then I subtract the exponent. But in this case, I would have 5 minus -3. When I minus a negative, that's going to turn positive, so 5 plus 3 is 8. So I would have y to the 8th power. Okay, that's nice. That really cleaned things up. And then that is to the -1/2 power. So then I'm going to distribute the -1/2 power to both of these exponents. So that means I'd have 4 to the -1/2, and then I'd have y to the -4th when I multiply. Okay, so now with both of these exponents being negative, I need to move both of them to the bottom. So I'm going to have a placeholder of 1 on top, 4 to the 1/2 on bottom, and then y to the 4th. Okay, so the y to the 4th, nothing needs to be done there, but the 4 to the 1/2 needs to convert. Remember, to the 1/2 power means square root, so this really means square root of 4 only, y to the 4th. So the square root's only being applied to the 4. So that would be 1 over 2 y to the 4th. And then you would be finished with that problem. Okay, nothing more can be done. Now looking at 7, it's very different from 6 because inside the parentheses I can't simplify. I don't have common bases. X and y are different bases, so nothing can be done inside. So then I'm going to go directly to my power to power rule. Well, when I have power to power with a fraction, I have to include multiplying that power to both the numerator and the denominator. So this is going to be x to the 4, so that'd be 8 over, and then that would be y to the -6 when I multiply both of those by 20. Okay, so on this, the x to the 8th is fine, but you can't have a negative exponent here, so x to the 8, that's going to move that y to the top to be y to the 6th, and that actually ends up being a pretty nice answer. Okay, all right, just a few more. Okay, here, again, rely upon PEMDAS big time. I'm noticing in the parentheses here, nothing can really be done, but I do notice here 4 can convert to 2 squared. So I know that seems like kind of tedious, but in the end, when you start practicing this more and more, I think you're gonna like what that'll do for you, especially when you start working with larger numbers. So I'm gonna convert 4 to 2 squared, and I'm just leaving everything else as it is. Then I'm going to distribute my power to powers, okay, and so that's going to produce 2 squared x squared y to the 1/2, okay, times 2 to the first. See how nice that made that? Y to the 1/2. Okay, and then I'm going to clean up a little bit more before I multiply these together. So this is 4x squared y to the 1/2 times 2y to the 1/2. Okay, and what I really want to zoom in on here is that a lot of you see something like this and think it's not legal. You think it's not legal because you're used to it not being legal when you add and subtract, because these are not like terms. So you're right. If I was adding and subtracting, I couldn't do this. I couldn't add these. They're not like terms. But you're multiplying. It's legal. You multiply by looking at the numbers in front. So 4 times 2 is 8. And then you would have x's together, but this term doesn't have an x, so it's just going to keep the x squared from this term, and then both terms have y, so remember, when you multiply like variables, you add their exponents. So it's going to be y to the first power, because 1/2 plus 1/2 is 1. So it's perfectly legal, and that's how you do it. So your answer is 8x squared y. Okay, next problem, a problem that you're going to see where converting these larger numbers to smaller numbers with exponents comes in very handy. So here, if I went ahead and distributed this 3/2 into both of these, I'd be dealing with some pretty ugly radical expressions. Instead, sometimes it works out nicely if you convert 4 to 2 squared and 25 to 5 squared, then raise that to the 3/2 power. See what that does for you. So when I distribute this 3/2 into both exponents, how nice is that? That's 2 to the, what's 2 times 3/2? Well, it cleans up nicely to just 3. And then what's 2 times 3/2? Again, cleans up nicely to just 3. So you have 2 to the third, 5 to the third. So you're talking 8 over 125. And then that cannot simplify anymore, so you're done. Okay, another situation where converting is going to come in very, very handy. So I know, and you'll start to learn, you'll get used to, 32 is 2 to the 5th power. Okay, so 32 is 2 to the 5th power, so I'm going to convert that 2 to the 5th and then to the 4/5. So I would have here this 5 times 4/5. Well, 5 times 4/5 cleans up very nicely. So this would just become really -2 raised to the 4th power, because 5 times 4/5 would be 4. So -2 to the 4th power would be +16. Okay, so last one here, and I really wanted to work this one because it comes up as a common question, is how would this work out? It's very similar to this, but not quite the same. So if you knew that 32 is 2 to the 5th power, take 32 and multiply it by 2 one more time, and what would that produce? That would produce 64. So that means 64 must be 2 to the 6th power. Okay, so I'm converting 64 to 2 to the 6th power first, and that is being raised to the 2/3 power. I know that looks real nice, doesn't it? So I've got 2 to the 6th power raised to the 2/3 power. But this is different because the negative is not in the parentheses. So I'm going to distribute multiply 6 times 2/3 to give me -2 to the 6 times 2/3 would give me 4th power. Okay, but this answer is going to turn out very differently. You're going to keep the negative and it's going to be 16. Because really what's happening here is you're only raising 2 to the 4th power, not -2 to the 4th power. The negative stays out in front. Okay, it remains. It's very different from if the negative is inside. So I just wanted to make that very clear for when something like that arises.